Come to the receive side of the Harvard 020 200 milliwatt hand portable. I'll just set this on frequency exactly. So we're on 2789125, which is channel 30. This particular version offers channel 14 and channel 30. The very early version was 19 and 30. You'll find there's other 2-channel crystal controlled hand portables of the same era, and they followed the same channel pattern, which was quite handy. So where do we start? Well, the manufacturer says that the sensitivity ideally will be better than 0.5 of a microvolt, which is in line with a normal transceiver. The limit specification is 1 microvolt. Well, right at the moment that's 3 microvolts. So we're going to start tuning this up at 3 microvolts. To get it on frequency, and I think we can do that with transformer 7, but don't quote me on that yet. What we're going to do is use a marker oscillator, and I'll come to that in a moment. So first of all, what you're supposed to be doing is to be using a sweep generator. Well, we haven't got a sweep generator on this bench. In October, when we're set up with the other benches here, we'll have a sweep generator here. So what we will just do is we'll just try and guesstimate that. So adjusting, there's 3 IF 455 kilohertz transformers, and the first one is 1 there, the transformer 10, right at the end. Now that sounds like the detector to me, so we'll just look for absolute maximum mod. Because it's only 250 milliwatts output amplifier, I'll just move my oscilloscope to a more sensitive position. We'll just maximise the waveform. Which I seem to have been able to do. Now, whether or not we can do the same with 12 and 11 remains to be seen. Yes, I can. So I've got a Synad meter in front of me. It's a bit noisy, could do with a spray. Just go through these again. Now that's 1 microvolt. So now we'll tune the actual receiver itself. I'll just try and turn the volume down. It's got a bit of a flat spot there, I'll clean that later. And then we're going to use transformer 8. That's okay, that's already in the correct position, and transformer 9. Also in the correct position. Now what we're going to do, I'll just pause the video while I set up the 455 kilohertz marker oscillator. So what I've now done is to set up the 455 kilohertz marker oscillator, which is a small portable signal generator And if I'm right, then transformer 7 will set the frequency. So if I move the output of the device there, we've got a musical note. So hopefully with transformer 7 I can null that. Now that means it's now spot on frequency. So we'll switch the generator tone back on. And we appear to be greeted with nothing. So I may have stopped all oscillation. I have. So it's going to be a compromise. So put the generator back off to its no modulation position. Marker oscillator back on. And that's as low as I dare take it. So I'll just put the marker oscillator back. And we'll just check there's no improvement can be gained with that IF. So this should have been done with the sweep generator. So now it's on frequency. That's why I'm just going through it again. So 10 microvolts, 3 microvolts, 1 microvolt, 0.3 microvolts. Well, the manufacturer says 0.5, and that's 0.5. So it's certainly doing what they say it does. Now it's got a preset squelch control, which is there. The manufacturer says that should come in at 3 microvolts. Well, that's 10, and it cuts off at 3.5. So it's round about what they say, so that's fine. So we've brought it on frequency by carefully adjusting T7. In my demonstration there, the crystal stopped oscillating, so I just had to wind it back a bit. So it's minutely off frequency, but it's just so little it really doesn't matter. And then we've very carefully done the IF, transformer 10, transformer 11, transformer 12. They should be done with the sweep generator, but I've done it with the Synad meter and the ordinary signal generator very carefully. And then the actual receiver itself is receive number 1 is transformer 8, receive number 2 is transformer 9. Remember, this is a single conversion receiver, it only has a 455 kHz IF. And then I've used a marker oscillator on 455 kHz to nearly null the frequency, as we said, but I just couldn't quite do it, it would have gone so the crystal doesn't oscillate. And so there we have it. What I'm now going to do is put the radio back in its case, and then we'll have to set up the loading coil of the telescopic aerial with the field strength meter, and I will do that in a moment. Now this is going to be the awkward bit. So I put the radio printed circuit back in the case, got a field strength meter out here, and when we press transmit, I'm getting a deflection on the meter. Now we've got to make sure that's going to be maximum. So what I'm just going to do is now adjust the transformer number 1, which is I indicated to you before, which is next to the PTT switch. I've just melted the wax in the coil, so press transmit, and now make sure that that is peaked, and that was peaked. So we know that now is the telescopic is fully extended. I've made that adjustment, and Bob's your uncle.